Hey, this is Mr. Ariel with the Part 2 screencast for atomic bonding. Now, there are three types of bonds that atoms can make, and so far we've learned about ionic bonds. We've got covalent bonds and metallic bonds left to learn about, and so today we're just going to focus on covalent bonds. Let's go ahead and get started. Now, covalent bonds are the bond that forms when two non-metal atoms share electrons in order to have a stable octet. Reaching back to ionic bonds, remember those are the bonds formed when an atom gains or loses electrons and becomes an ion, and those are atoms with a positive or negative charge. For covalent bonds, atoms don't gain or lose, they simply share them in order to reach the stable octet. Now, why does the definition include the words non-metal? Why does it have to be those kind of atoms? Well, it's because metals that are over here on the left-hand side of the periodic table, they just can't make covalent bonds. After all, if you took an atom of lithium and it has one valence electron because it's in group 1, and you took a magnesium that's in group 2, it's got two valence electrons, well, there's no way for these two atoms to share those electrons in order to end up with a stable octet. Instead, atoms that form covalent bonds tend to be non-metals. Those are the ones on the right side of the periodic table. And you probably remember from a previous lesson that most nonmetals have an almost full outer energy level. And the noble gases, in fact, have an entirely full outer energy level. But they don't make bonds because they're already full. So let's get an example of a covalent bond into your notes. I'm going to look at oxygen that's right here on the periodic table. Now the oxygen that we breathe is actually O2. It's two atoms of oxygen bonded to each other with a covalent bond. So I need an electron dot diagram. So I'm going to draw in two oxygens. That's the first step, is basically write the symbol of the element. And then oxygen is in group 16, so it's got 6 valence electrons. And so I'll simply draw those in. Now, because both of these atoms lack 2 electrons that they need to make their outer shells full, there's a spot right here, there's a spot right there, and then there's 2 more spots over on this one. Neither one of them is currently stable. Let me take those boxes back out of the way. Now, what these oxygens will do to become stable is one of them will move an electron to be close to the other atom. Technically this electron right here on this right-hand side oxygen, it belongs to that oxygen, but it's going to be close enough to this left-hand oxygen that what it's going to do is once in a while, it's going to find its way into an orbit around the left-hand side oxygen. And so for all practical purposes, that means this left-hand side oxygen has 7 valence electrons that are going around it. Now, that's still not stable. An atom needs 8 valence electrons in order to be stable. And so what happens next is another one of those valence electrons on the right-hand side oxygen moves close enough to the left-hand side oxygen in order to orbit around that left-hand side once in a while. And it's enough to make that left-hand oxygen stable. But what about this oxygen over here on the right? It only has 6 valence electrons. Well, what happens there is the same thing we've already done. These 2 valence electrons will be close enough to that atom that once in a while, they will find themselves orbiting around the right-hand side electron cloud. It's just once in a while, but it's enough of the time that the oxygen on the right has a stable octet. Now, drawing all these circles and all these dots can be kind of confusing to look at, and so let me show you a simpler way to draw this out. Covalent bonds are often drawn with a solid line to represent each pair of electrons that are being shared between the atoms. And that would simply be rewritten as oxygen, and then there's 2 bonds for 4 electrons, and then these unshared electrons are simply drawn back into their places. Now let's get one more example into your notes just for practice, and so you can also see a different way of drawing things out. Nitrogen gas makes up about 78% of the air we breathe, and its chemical formula is N2. That means we have 2 nitrogen atoms, and that's in group 15, and each nitrogen has 5 valence electrons. So let me draw those electron dot diagrams in. And remember that each atom needs a stable octet, but each one of these nitrogens only has 5 valence electrons. So each atom can share 1 pair of electrons, kind of like this. And if I was to update my drawing, right now we have nitrogen, and that shared pair of electrons is a single bond. And if we counted up our electrons around the left-hand nitrogen, there's 1, 2, 3, 4, 5, and then this one counts because it orbits around the left-hand side once in a while. And the same would be true on the right. This nitrogen over here would also have 6 valence electrons. And so now we just need to repeat the process and share another pair of electrons. And so that means I just made a double bond, and each atom would have 7 valence electrons. Now neither atom has a stable octet yet, but sharing one last pair of electrons right here would get us a triple bond. And let me just recount to make sure I did it properly. This nitrogen has 1, 2, 3, 4, 5, 6, 7, and 8 valence electrons. And of course, the same would be true around the right-hand side nitrogen. Now, the last step at this point is that we need to draw in these unshared pairs of electrons. They need to go on our finished drawing down here. And so we can put them right here. There's 2 on each, and my drawing is complete. Now, that's it for the notes today. I hope this video has been helpful to you, and as always, thanks for watching.